Yeah.
So would it be asked for the acceleration?
It could be. I mean, I think I'm missing what the ultimate question is here. You're thinking of what kind of problems I might ask with this, or?
How does the acceleration fit into that?
I was just finding the acceleration due to gravity using the generalized formula. And we saw that we got pretty darn close to the same value.
Hopefully. Unless I messed up again.
All right. As usual, I know what you're thinking. You're thinking, great, but we were just doing centripetal force. Can we actually do a centripetal force problem? Yes, we can.
Yeah, that's exactly what I was thinking.
You read my mind.
It's opposite because I was thinking. That's what I was saying. That's what I was thinking. I think we all are. I think we all are thinking that. Sorry guys, it's been a long day already.
I have a satellite that is orbiting Earth. Actually, let's talk a little bit about orbits. Newton sort of figured, you know, if you take an object, let's say I've got a hill here and I've got a cannon sitting on top of it. If I shoot a cannonball, it's going to, well, hopefully that's not a shock that if you shoot something, it will fall.
Right.
If I expand, if I shoot even farther, or faster, I should say, it's going to go farther, but at some point, I'm going to have to start taking into account the fact that the Earth curves. So as I shoot faster and faster, it will go farther and farther. And that, in theory, at some point, if you could shoot an object so that its arc of its fall matches the surface of the Earth, well, you have an object that's orbiting. So there was a line from, I want to say the Phantom Toll Booth, that you fly by throwing yourself at the ground and missing. This is basically what's happening here. Something's being thrown at the Earth, but it just keeps missing. So it's constantly falling and ends up back where it started.
Okay.
As long as you don't have anything that's slowing it down, don't have any additional force other than the gravitational force, it will continue doing that. So I have a satellite that has an altitude of the radius of the Earth. And I want to know how fast is the satellite going. So we start as we do with so many problems. What are the forces acting on the satellite?
But we're.
Force of gravity.
Now there's also a force of gravity acting on the Earth. All right, any other forces acting on the satellite?
Would normal force apply here? I don't
What's it
think
touching? Normal force requires contact.
Nothing. So then no.
All right, so we have this force of gravity pulling down. The direction of acceleration?
Is it going clockwise or counterclockwise in the process?
It does not matter.
Towards the center of the Earth.
Yeah,
How's that?
as Abigail had said.
Keep
So
thinking
my
around
acceleration
it.
is in that direction. Decomposition, do I have to break it up? I hope not. If you have one force and you have to break it up, you have probably chosen the wrong direction for acceleration. Our coordinate system, I'm going to go ahead and make that the positive direction.
Right.
So my equation of motion,
Your equation.
Positive I hat.
Is it in there?
sure.
Okay.
Okay, wait, actually, it's not close.
So I have big G, mass of satellite, mass of Earth, over R squared is equal to mass of the satellite times V squared over R. Mass of satellite cancels out because the mass really doesn't matter of the object in terms of once it's in orbit. It would make a difference if you have to launch it, but not at this point. And so the speed is the square root of G times mass of the Earth over R. 6.67 times 10 to the negative 11th times mass of the Earth, which is 5.98 times 10 to the 24th, divided by R. R is center to center, so it's going to be twice the radius of the Earth. So 2 times 6.38 times 10 to the 6th.
2 times.
How'd you get that 6.38 number?
Radius of the Earth.
Do you just know that off the top of your head?
Yeah. It would be something you would, if you don't know it, you look on the first page.
Then what's the 5.98?
Mass of the Earth.
Mass, okay.
Again, something that you just look on the first page if you're not sure what it is. So what do we get for the speed?
Did we get? I don't know, wait. Divided by 2. Is 10 to the 6th?
You have something times 10 to the 6th, did you
No,
do
no,
square
I was
root?
saying, is that times 10 to the 6th?
Yes, that's times 10 to the 6th.
3.65 times 10 to the power of, I don't know what that means. 10. Just 10. Yeah.
To the power of 1, 0, 2, 3.
Oh, that to, so 3.65 to the power of 10?
Times 10 to the 10th?
I'm not sure. I don't know how to read this. I thought I did, but I guess I didn't.
That's times 10 to the 10th.
Yeah.
Okay.
Did you do the square root? All right, I'm gonna guess,
Yeah, I did.
considering this exceeds the speed of light, and we do have satellites, I'm going to guess that when you type this in, you did divided by 2, and then parentheses 6.38 times 10 to the 6th.
Yeah.
Did you put parentheses around the whole thing?
No.
So you multiplied by this instead of divided by this,
Oh.
which would definitely change that number.
Is that 5.98 times 10 to the
Yay.
6th?
5.98 times 10 to the 24th.
It's a big number.
Times 10 to the 6.
It is.
Just start writing out like 24 zeros.
9.8.
Don't, it'll take way too much time.
3 times 10 to the negative 15.
That seems way too small.
Rocks. Dude, you. Someone pull out
5,000.
Desmos.
That sounds more reasonable. 5,000
5,590.93
Enough.
units.
meters per second.
I got, you guys got 590? Same.
All right. So it's traveling at about 11,000 miles an hour. And then you can extend it further. How long does it take to go around? Is it traveling fast enough that you can actually see a satellite moving? And yes, it is possible to see some satellites moving with the naked eye.
Wouldn't it be very specific square?
This, we're solving for speed here.
Oh.
Which do we do after class?
Uh,
Okay.